So in this video we're going to talk about absolute value and comparing and ordering numbers. All concepts that you've learned before, but now we're going to kind of put it all together. So let's do some definitions and review. First of all, absolute value is the number's distance from zero on a number line. It's not just taking a negative and making it positive, or positive and making it negative. You actually have to look at how far is this number from zero. If it's negative, it will end up positive though, because absolute value is always positive. An inequality is a math sentence that compares the values of two expressions using the symbols greater than, less than, or equal to. You know we can also have something that's greater than or equal to, or less than or equal to, when we deal with inequalities. Vic number one, or very important concept number one. Distance can never be negative. So absolute value will always be described as a positive value, which I've already said. Alright, let's keep going. So let's find absolute value. Remember, absolute value is denoted using the two bars. If we want to find the absolute value of 6, it's just 6, because it's always positive. The absolute value of negative 4 is 4. Absolute value of negative 4.3 is 4.3. Okay, let's keep going. What if we have some work to do in there? We have 5 plus the absolute value of 3 plus negative 2. So this absolute value symbol works a lot like parentheses, and we use order of operations. So we do 3 plus negative 2. So that's going to take us to be 5 plus 3 plus negative 2 is just 1. So now we're doing the absolute value of 1 plus 5. So your final answer here is going to be 6. What about this one? 20, absolute value of 20 plus the absolute value of negative 10. Well, the absolute value of 20 is 20. The absolute value of negative 10 is 10. So our answer will be 30. And then we have this one. Two problems to solve. The absolute value of negative 6 plus negative 2. This gives you negative 8, but your absolute value would just be 8. Plus, the absolute value of 3 is 3. So your answer is going to be 11. So remember, use your absolute value symbols like parentheses and solve what is inside first. And then do your further work. Okay? What if we want to order and compare numbers? Let's say we're going to go from greatest to least. First of all, let me caution you. Make sure you read the directions. Does it say greatest to least or least to greatest? People miss problems all the time simply because they don't read the directions. So in this case, if we're going to go from greatest to least, let's start by making it a decimal because they're easier to work with than fractions. So if we're going to change to a decimal, 2/5 becomes 0.4 or 4/10. 1/2 becomes 5/10. And 2/3 is 0.66 repeating. So when we go to take this from greatest to least, we would say 0.66 repeating, 5/10, and then 4/10. And then we could put it back in decimal form if we wanted. 2/3, 1/2, 2/5. Okay? What if we wanted to go from least to greatest and look at this number? We have 7/11, 0.63, 0.636. Okay, so 7/11 becomes 0.63636363. Okay, then we have 0.63 and we have 0.636. Well, we are going from least to greatest, but these numbers sure do look a lot alike. So your smallest would be 0.63 because it stops, because our next number here would be 0. Okay, next would be 0.636 because this stops here, but our next number would actually be 0. So that makes it the second smallest. Now this one, 0.636363, is going to be our final number because it keeps going. There is no 0. So then if we converted it back to a fraction, we get that our numbers in order from least to greatest go 0.63, 0.636, and then 7/11. Okay. So let's use inequalities to compare. Alright, so let's say we have 2/3 and we have 1/6. We can compare them and we know that 2/3 is greater than 1/6. How? Because we can look at the decimal form. This decimal would be 0.6 repeating, which makes it 0.6666. This one is 0.166666. This is greater than this. What about this one? 15/8 is greater than 1 6/8. If we make them both into decimals, we get 1.875 and 1.75. We can see that this is larger than this. Always change it to a decimal, it just makes it faster. Looking at this, 0.35 or 3/5, excuse me, not 0.35, just 3/5 is equal to 0.6. If we change 3/5 to a decimal, we get 0.6. It's going to equal 0.6. Okay, so what about when they're negative? Remember, the larger looking a negative is, it's actually smaller. Or let me state that another way. The closer it is to 0 on the negative side, the larger the number is. So if we have negative 2/3, that number represents negative 0.6 repeating, or 0.66666. If we have negative 1/6, that represents negative 0.1666. Up here, we said that 2/3 is greater than 1/6. Down here, we're going to say that negative 2/3 is less than negative 1/6, because on a number line, this number would be closer to the 0. That's how you compare and order numbers.